Okay, so now we want to talk about some calculations that we perform using moles. So we need to look at our conversion factors first, because all the calculations that we do with moles are essentially just unit conversions. So our main conversion factor that we have, or one of the main ones, we know that there are 6.022 times 10 to the 23rd, we'll say particles. And we'll say that N are equal to 1 mole of particles. Okay. So then the other conversion factor that we have takes us back and forth between moles and grams. So to go from moles to grams, we're going to use molar mass. Okay. So rather than, it's different for every single atom and molecule, so I'll just write molar mass is the conversion factor for mole to grams. Okay, so that's how we go from moles to mass there, but it's different for every single atom or molecule that we have there. So notice there is no conversion factor that takes us, and let me back up. I know I wrote particles here again. Hopefully that means that excuse me, I can't talk. Hopefully you know that refers to either atoms or molecules, something of that nature. So notice there's no conversion factor that takes us directly from grams or mass to number of particles. So there actually isn't one there. So in your notes you have a nice little diagram typed out where you have mass, moles, and then number of atoms / molecules. Okay. So we can convert from mass to moles and moles to mass, and our conversion factor there is molar mass. And we can convert from moles to number of atoms, or from number of atoms to moles, and our conversion there, or conversion factor there, is Avogadro's number. So even though we can't directly convert from mass to number of atoms or number of particles, if we can convert from mass to moles, then moles to number of atoms, we should be able to go back and forth pretty easily. So let's look at a few problems and a few of these calculations. So I could ask, how many grams does 2 moles of sodium weigh? So if I ask you how many grams does 2 moles of sodium weigh, essentially what that's asking you is to convert from moles of sodium to grams of sodium. Okay, so this is just a dimensional analysis problem like before. So let's start off just writing the given. So write what we start with, 2 moles. I know the unit of moles. Let me start that over. Let's go ahead and write out 2 moles of sodium. Okay, so go ahead and write out 2 moles of what you actually have, because the atom will make a difference here. So 2 moles of sodium. Go ahead, and we know these units go down here automatically. So moles of sodium, because I have to cancel those units out. And I'm ultimately trying to find grams of sodium. So do I have a conversion factor that takes me from grams of sodium to moles of sodium? Yes, I do. I know that 22.99 grams of sodium is equal to 1 mole. So where did I get that number from? That is the molar mass from the periodic table rounded to 2 decimal places. So I type that in the calculator, 22.99 times 2. And then notice here, I only have 1 significant digit in my problem. I don't worry about the significant digits of the conversion factors. You only consider the significant digits of the original number in the problem. So I round my answer off to 1 significant digit. So my final answer is 50 grams of sodium. Okay. So now let's ask kind of the reverse of that question. Let's ask something similar to, we'll just say 75 grams of sodium is how many moles? So the same basic process here. I start off with what I'm given, 75 grams of sodium. I'm trying to cancel these units so they get dropped to the bottom, grams of sodium. I'm trying to go to moles of sodium. And I need a conversion factor to carry me from grams to moles, and I have that. It's the molar mass, 22.99 grams in 1 mole. And I didn't do it up here, but I should have. You should always go back and cancel your units. Make sure you're left with what you need. So here I'll cancel my units, grams of sodium, grams of sodium. I'm left with moles of sodium. So I type in 75 divided by 22.99. You should get 3.262 and some more numbers, but I only have 2 significant digits in my original problem, so I round my final answer to 2 significant digits. 3.3 moles of sodium. So fairly easy conversions there. So really that's the only 2 types of problems you could be given that deal with moles and grams. You can go from moles to grams or grams to moles. I could change these and make up thousands of different problems, but the only difference would be the atom or the molecule. So if it's a molecule of more than one atom, if this were sodium chloride, for example, instead of using the mass of sodium, you would just use the mass of sodium chloride. Okay, so the process stays the same. All that changes is the identity of the molecule, which changes the molar mass. So now let's look at a different type of problem. Let's say, how many atoms are in 3 moles of silver? Okay. So basically I want you to convert from moles to atoms here. So let's start off with 3 moles of Ag. I drop moles of Ag down here. I'm trying to cancel it. I need to have atoms of Ag on top. And now you have to ask yourself how many atoms of silver are in 1 mole of silver. So hopefully you remember there are 6.022 times 10 to the 23rd atoms of silver in 1 mole of silver. So did this problem even matter that it was silver? No, it really didn't. Because once you're in moles, the identity has no effect here. You only worry about the identity of the molecule if you're dealing with the molar mass in grams. So we can type this in the calculator. 6.022 times 10 raised to the 23rd power times 3. And I only want 1 significant digit here in my original problem. So round my answer to 2 times 10 to the 24th atoms of silver. So then I could do the exact opposite of the problem. I could give you a large number of atoms and ask you how many moles there are. So let's do one that's a little bit different. I want to know, I think I'm going to word this. Okay, so this one's slightly different. I ask how many bromine atoms are in 3 moles of magnesium bromide. Okay, so this one's a little bit different because I tell you you have 3 moles of magnesium bromide, a molecule, but I ask you how many atoms there are. So let's think about what this means. So for every 1 magnesium bromide, there are 2 bromines, because every magnesium bromide molecule has 2 bromines there. So hopefully, once we start the problem, it'll make sense how we account for that. So let's go ahead and set it up like normal. So I have 3 moles MgBr2. I drop down moles of MgBr2. On top, I don't write atoms of MgBr2. I write molecules of MgBr2 or particles of MgBr2, because the definition of Avogadro's number applies to whatever we're talking about, whether it be atoms or molecules. So here it is molecules. So I can write MOLEC to abbreviate, MgBr2. So there are 6.022 times 10 to the 23rd molecules of magnesium bromide in 1 mole of magnesium bromide. Okay? So if I got the answer here, I wouldn't answer the question. That's not what I asked you for. I asked you how many moles of bromine there are. So I need to do one more step. I need to cancel out molecules of MgBr2. And I need to end up with the final units, atoms of bromine. Do I have a conversion factor to go from molecules of magnesium bromide to atoms of bromine? Yes, I do, and it's right here. There are 2 bromine atoms for every 1 molecule of MgBr2. So let's go ahead and cancel our units. Moles magnesium bromide, moles magnesium bromide. Molecules of MgBr2, molecules of MgBr2. I'm left with atoms of bromine. I ask you for atoms of bromine. So I'm on the right track. So let's type this in the calculator now. 3 times 6.022 times 10 raised to the 23rd power times 2. So I only need one significant digit from the original problem. So my final answer is 4 times 10 to the 24th atoms of bromine. So hopefully you see why we had the extra step in this problem as opposed to this problem. Because up here, you started off with moles of atoms. I asked you for number of atoms. But down here, we started off with moles of a compound or a larger molecule, and I asked you for number of atoms. So be careful if you are asked for a specific atom and you're given a larger compound, you have to account for that in a step. Okay, so now let's look at some calculations that go back and forth between grams and number of atoms or number of molecules. So let's just say 25 grams of nitrogen is how many moles of nitrogen? Excuse me, we'll say is how many atoms of nitrogen. So hopefully you realize that we cannot go straight from grams to atoms. I don't have a conversion factor for that. But I can go from grams to moles and then moles to atoms. So let's try that. So 25 grams of nitrogen. So if you watch this video later in the year as a review, you'll realize, hey, this isn't exactly right. Because you'll remember that nitrogen is a special molecule. It's diatomic. It always exists as N2. But for now, we don't know that yet, so we'll ignore it and just go with grams of nitrogen. So we have 25 grams of nitrogen. I drop down the units of grams of nitrogen. So ideally, I would like to go ahead and put atoms of nitrogen up here. But if I put atoms of nitrogen up here, I would have to have some type of conversion factor to go back and forth from atoms and grams, and I don't have that. So I can put moles of nitrogen up here. I do have that conversion factor, okay? So I'll fill that in a moment. Let's go ahead and finish out the units though. So then I drop down moles of nitrogen. Now finally I can go to atoms of nitrogen. So if you're ever doing a problem and you accidentally forgot to do the middle step and try to do it on one step, hopefully when you tried to plug in the conversion factors you would realize that conversion factor doesn't exist, so you would go back and start the problem over. So my conversion factor from moles to grams is the molar mass. So there are 14.01 grams of nitrogen in 1 mole of nitrogen. That is simply the mass of nitrogen from the periodic table. And then the number of atoms in 1 mole of nitrogen is 6.022 times 10 to the 23rd. Okay. So I double check my units. Grams cancels grams, moles cancels moles. I'm left with atoms. The problem asks for atoms, so I'm on the right track, at least I know that. So plug in the calculator. You should get, and we need 2 significant digits, so you should have 1.1 times 10 to the 24th power atoms of nitrogen. So if you set the problem up correctly and got the wrong answer, a very wrong answer, you can go ahead and type in the calculator again and try putting parentheses around this number right here. A lot of the errors we get are because you actually do an operation with the exponent when you should be doing an operation with only the number itself. So go back and try that again if you missed it. Okay, so let's try another one. Let's say 2.4 times 10 to the 23rd. We'll say atoms of, we'll change it up and say magnesium is how many moles? No, excuse me, not moles. We'll say how many grams. Or another way to word that is, what is the mass of 2.4 times 10 to the 23rd atoms of magnesium? So there are many different ways to word these problems. Just be sure you read it closely and know what I'm actually asking for. So no matter what the problem is, we started off the same way here. We have 2.4 times 10 to the 23rd atoms. Just write what you're given. Go ahead and drop that down. These units go down here. So atoms, mg. So I can't go straight from atoms to grams, but I can go from atoms to moles. So I can go to moles of mg. I drop those units down here. Moles of mg. And then on top I will have grams of mg. So do I have conversion factors for all these? Hopefully yes I do. There are 6.022 times 10 to the 23rd atoms in 1 mole. Then for magnesium, I look at the periodic table, I see the molar mass is 24.31, so there are 24.31 grams in 1 mole of magnesium. I go back and double check my units. Atoms cancels atoms, moles cancels moles, I'm left with grams. What did I ask you for? I asked you for the mass. Grams is a unit of mass, so I'm in good shape. So I type this in the calculator, and I should get 9.6884. So we have 2 original significant digits in the problem, so I round my answer off to 2 significant digits. So there are 9.7 grams of magnesium in 2.4 times 10 to the 23rd atoms of magnesium. Let's go ahead and try one last problem. Let's say, what is the mass of 1.2 times 10 to the 24th molecules of NaCl. Okay. So I start off with what I'm given, 1.2 times 10 to the 24th molecules NaCl. So what I start off with goes on bottom, molecules NaCl. And ideally, I would like to go ahead and put grams, the mass, on top. But I don't have a conversion factor to go from molecules to grams, so I have to go through moles first. So I do moles NaCl. Then I drop moles on bottom, moles of NaCl, and I have grams of NaCl. So now I go back and make sure I have conversion factors for all these. Do I have a conversion factor that goes from molecules to moles? Yes, I do. There are 6.022 times 10 to the 23rd molecules in 1 mole. Now for the conversion factor from grams to moles. Do I have one there? Yes, I do. It's just a little bit different because it is a molecule here instead of just a single atom. So I have to go to the periodic table and add up the molar mass of sodium chloride. So I should get 58.44 grams of sodium chloride and 1 mole of sodium chloride. Before I type it in, I'm going to go back and double check my math, or excuse me, my units. Molecules cancels molecules, moles cancels moles. Grams of NaCl is what I have left, and then I ask for mass, so I'm in good shape. So if your units don't cancel, you know you're wrong. There's no point continuing forward. So type this in the calculator and see what you get now. So when you type it in and round to 2 significant digits, you should get about 120 grams of NaCl. So if you're getting an answer that's wildly different, like something raised to the 46th or 45th power, when you type it in the calculator, try putting the numbers with large exponents in parentheses, okay? You don't necessarily have to do that with all calculators. Just figure out your calculator and what you need to do to get the correct answer. You'll never have an answer with anything raised to the 40-something power. So if you ever get an answer that large, you know you've gone wrong, okay? So just do a quick review. If I want to go from grams to moles, I can do that in one step. If I want to go from moles to grams, I can do that in one step. My conversion factor is the molar mass. If I want to go from moles to, I'll say atoms slash molecules slash particles, I can do that. If I want to go from atoms or molecules or particles to moles, I can do that in one step. My conversion factor is Avogadro's number. But if I want to go from atoms, molecules, or particles to grams, or if I want to go from grams to atoms, molecules, or particles, I can't do that in one step. Okay, there has to be an intermediate step. I have to have mole as my intermediate step. Then I can go back and forth pretty easily.